if we use the coordinate plane to prove some geometrical result, that's sometimes referred to as a coordinate proof. And I want to illustrate that by proving the following result. So here we go. We've got a bunch of givens, and then we're asked to actually prove something. So, the right triangle ABC has vertices located at 0, 8, 0, 0, and 5, 0. We're told that D is the midpoint of the line segment AC, and our mission is to prove that the area of triangle ABC is twice the area of triangle DBC. Now, all that alone doesn't make a lot of sense to me until I produce a picture. So let's actually right now try to generate a picture for the situation. All right, well, here we go. So let's put in the points. So A is located at 0, 8. That's 0, 8. That's right here. So here's A. B is, well, it's located at the origin. That's B. And C is 5, 0. So this is C. So now I can see the right triangle. I'm going to draw it in. Now you want those lines to be straight. In fact, if you really want it to be straight, you could use a straight edge. I'm going to use a straight edge because you know why? I want you to see them as being really straight. I don't want you to think that I'm doing stuff sloppy, because I don't ever want you to be sloppy, especially in math, but even in life. Of course, I'm being sloppy now. But here we go. Drawing these in. Beautiful, beautiful. And then here is the hypotenuse. Remember, it's a right triangle. We know which angle is the right triangle. The right angle, it's right here. So there we have it. Great. Now, what else do we know? We know that D is the midpoint of AC. So D is the point that cuts this segment into two equal pieces. And I'm just going to eyeball it and put it right here. And I'm going to call that D. And now what are we supposed to prove? We're supposed to prove that the area of this original red triangle is twice the area of some new triangle. What triangle is that? That's triangle DBC. This triangle right here, which I'm going to draw in green with my straight edge. You can see to go on part of these line segments, and this actually is the same. There we go. Well, how are we going to prove that the area of this triangle is twice the area of this? Well, what I'm going to do is I'm actually going to compute the areas of each of them and see if numerically this statement is true. Well, finding the area of the red triangle is actually really easy because this triangle is a right triangle, so I know the formula is 1/2 base times height, and so this is going to be really, really easy because of the way we're using our coordinate axes. So the area of triangle ABC equals, well, 1/2 the base, which is 5, times the height, which is 8. And I can cancel here. 8 over 2 is 4, and so I see this is actually 20. So 20 units squared is the area of the red triangle. Okay, good. Let's put that aside, and we'll come back to that. What about the area of the green? Well, kind of hard to find. I guess it's 1/2 base times height. The base is 5, but the height is a little bit mysterious. How am I going to find the height? Well, one way to find the height is to find the actual coordinates of the point D. Well, D is the midpoint. D is the midpoint of the segment, so we can use the midpoint formula. Remember, that's basically just to take the average of the 2 points. And so let's find the midpoint D right now. So the coordinates for D are going to be what? Well, we take the average of the x's. So this x value here is 0. This is 5. So we take 0 plus 5, which is 5, and we divide it by 2. So 5/2. And then we take the average of the y's. So this y here is 0, and this y here is 8. So we see 8 over 2, which is 4. So the coordinates for this point we now see are 5/2, 4. In fact, it's not a bad idea if you're trying to draw this picture accurately to see if this makes sense. 5/2, that's exactly 2.5. And notice that in my picture, 1, 2.5. Wow, it looks pretty good. And what about the height of 4? It looks perfect. So my picture seems to conform with the mathematics. Well, if I know that this height is 4, well, then I'm in great shape. I can find the area. So the area of the green, so area of triangle DBC is equal to 1/2 the base, which is 5, times the height, and we just figured that out to be 4. And so once I take 4 and divide it by 2 and I get 2, I see 5 times 2, which is 10 units squared. And is it the case that the red triangle is twice the green triangle? It sure is. So I can see that this number is twice that number, and that proves the theorem.